Hi, it's product teardown time again, and we've got another Kindle. You know I love the Kindle. You know I've torn down a few of them previously and reviewed them. Well, we've got the new Kindle Paperwhite. Oh, so it's got the new LED backlight on the thing, so you can read it at night. Terrific. Not too many changes from the regular, from the previous Kindle Touch, really, apart from the Paperwhite display, they call it, which has the LED backlight on it. Should be interesting. Let's tear this sucker down, see what's inside. Let's go. Now, as for taking this thing apart, it does appear to be somewhat different to previous generation Kindles in that the back here, you'll notice, has no split along the edge, so the back case looks like it does not lift off anymore. That's totally changed, because if we look at the Kindle Touch, you can see that the back panel there can easily lift off. And of course, the first generation Kindle, I've done a teardown. You just go around the edge and you can lift off the back panel like that. But this new one the new Paperwhite is significantly different. So it looks like we're going to have to lift off this front bezel, because your edge is actually on the front. And what that means, if you're not really careful with your spudger going around the outside, you're going to be left with some pretty horrible marks around the edge. And yeah, no doubt I'll probably goof it up and leave a few marks on it, but let's give it a go. Okay, I'll use my plastic spudger this time instead of my metal one, so let's give it a go. Let's start over here and see if I can dig into this sucker and get this panel off. Could be a bit tricky. Let me try and start this without the camera in the way and see if I can get a foothold in there. Camera's just a bit awkward being in the way here. Well, my plastic one didn't really cut the mustard there, so I managed to get my metal one under there, and it does seem to have some adhesive on it. So going to have to be pretty careful. We'll work our way around this thing, and so yeah, it's a bit tricky, this one. It's got seems to have little dabs of adhesive all the way along it. Got to be careful not to damage the display in there, I guess, poking in too far. So yeah, this could take a bit. You should be able to see that adhesive in there. It really is a pain in the butt to try and get this thing off. I've got another plastic spudger. Yeah, check that out. Look at that. Horrible stuff, man. Previous Kindles were much easier to get open than this one. This is messy. So that top bit along there is really troublesome. It's really stuck down quite well. The sides really just pop straight off. And I presume the bottom here is going to be the same pain in the butt as... Oh no, it's not as bad. The bottom's not as bad. But, this is just horrid. Ta-da! We're almost there. Almost there. Oh no, I let it stick again. There it is. And we have a date code on the back of the front panel bezel here, the 21st of the 9th, 2012. That's almost exactly 3 weeks ago, and that includes shipping and everything like that. So there you go. It's pretty darn recent. I'm not sure if that's a manufacturer date code for the front panel bezel, or whether or not it was manufactured before that, and this was the assembly date code or something like that, perhaps. Most likely the manufacturing date code though. And it looks like to get access to the rest of it and lift it out, we've got a whole bunch of Phillips head screws around here. So let's have a crack at those, and the whole assembly should just lift out. Well, it's not coming out, so I suspect there's a hidden screw up under there. Little bastard. There's a couple of clips down the bottom here, so obviously this outer housing here actually, is that like a magnesium housing or something? I'm not sure, but that clips in under those two clips there, so clearly it's sort of leave it in down like that and put down, and then looks like we've got a final screw under there. Only one way to find out. Let's get the knife out. Have a look. Ta-da! Little mongrel. Nothing in the back of it. No, that's it. Ta-da! We're in. And if we have a look at the back of the case here, they've spared no expense. Of course, they have the RFID tracking tag, which they can use for production tracking. It'll have a serial number, a unique ID identifier built in. They can track it during production and stuff like that. And all metal threaded inserts in there. Beautiful. Good to see. They've really spared no expense. And here's the passive RFID tag, and it's passive because it doesn't have a battery in it. It actually generates a voltage from the antenna here and powers the chip inside, which then remodulates it and can send data out. I have no idea what the 293_1 is, a product code or some type of the device, and you can see the tiny little chip in there. It'll probably have like a little serial number or something embedded in it, and that's about it. And we have another date code inkjet or something printed on the inside of the case here, 24th of the 9th, 2012. Only less than 3 weeks ago. And the first thing I notice about the PCB is that there's hardly any unshielded circuitry. There's a tiny amount up there. There's one chip on that flat flex board there by the looks of it. A couple of passives or something around here, but everything else is under metal shielded cans. They're really knocking any issues with RFI right on the head, right there. And if we take a look at the battery here, it is Amazon Kindle branded, manufactured in Japan, and it's a model number MC 345-77503, 1420 milliamp hours. It's a single cell, of course, 5.25 watt hours nominal lithium polymer. And of course, it looks fairly easy to replace. Just a couple of screws. I'll have some PCB spring terminal contacts under there, and it'll just lift off. I like it. But they really could have gone for a larger battery if they so desired and really kicked the battery life out of the park. They could have filled up this entire area with a massive battery. Huge. We would have, at least doubled the capacity or something like that perhaps. But increased cost, increased weight, it's all a trade-off. And on the bottom edge of the board, you'll notice they've gone to all the trouble to have a little flat flex cable there just to house the little tactile dome switch for the power switch. And then they've gone over to an SMD header over there, and well, they've gone to quite a bit of trouble there. It's nicely engineered, but maybe expense they didn't need. They could have used a right angle tack switch perhaps on the board, maybe embedded into the board if they cut out a little bit of the board or something like that perhaps. Could have lowered their cost a bit more there, but that's well engineered. And right next to that, they've got an unpopulated footprint there. I'm not sure what's going on there. It's maybe some sort of soft power latch-in button chip or some sort of reset chip. I don't know, but they've decided to leave it off because there's not much in the way of I/O on that thing, so really, who knows? And this rubber thing here, believe it or not, is the LED. There it is. It shines out the bottom there, and that is sort of clipped onto the underside of the board as well, so it sort of slides on over. And why they've done that, I've got no idea. And the little micro USB connector here is a tiny little BGA chip there. I can't quite see that. I'll have to look under the ×10 microscope to get that. Another little bit of padding here. That's just, I don't know, maybe stopping the case or something like that, pressing down. And a couple of tiny little passives, and they look like 0201s or thereabouts. Ultra tiny. And actually, this trace here is very curious. Look at that. There's like an AC coupling cap there, and these look like resistors. Just a couple of series resistors here. I have no idea what that's doing. It almost looks like it's a controlled impedance trace that would go to an antenna, but that's... And there's that little BGA chip, AAC98V139. I have no idea what that one is. Now, somewhat curiously, on this flat flex cable going over to the PCB, we have a Macronix MX25U4035. And that, reason I say rather curiously, is because that is a 4 megabit serial flash chip. What's it actually doing on the flat flex cable there? Your guess is as good as mine. Now here is the magic of the Paperwhite display. It looks like we've got a couple of LEDs along the bottom here which light into this diffusion film here, which then goes over the entire top of the screen. And that adds, apparently there's a lot of technology that's gone into that film, into that diffusion type film that makes this thing give complete even light all over the entire screen. And the LEDs are ultra low power, ultra high efficiency LEDs as well that give the incredibly low power consumption. So this thing can get many weeks of battery life with the display backlight. I guess, well, you know, still call it a backlight even though it's more like a front light here, display. And you can see them lit up here. There they are, 4 LEDs which light up and then give a completely even display. I mean, look, you can't even see any shadowing in there at all. Maybe slightly on the screen, but in real life here with my eyes, I can barely see any shadowing on that, down that bottom at all. And that, it looks like they might have something LEDs up the top as well, but I don't think so. I just think that's the light coming out of the diffusion layer and traveling all the way through and just popping out the other end there. So it looks like it's lit somehow up the top, but that's just the light coming all the way through. It's really quite neat, and these LEDs are actually quite bright here in the lab. I'll see if I can capture that on camera. And I've completely switched the lights off in the lab here, so all I've got is some incidental light coming from through the glass windows at the side of the office, plus my exit sign. And wow, that is really bright. I'm not sure what this is set to, but geez, this really lights up. And of course, if you put your hand over that and you don't actually see that, because these are very blinding, but if you don't see them, that display is just beautiful in the dark. I love it. So let's go in and find out what level this thing is set to. We'll bypass all the Wi-Fi crap. And there you go, it's set to almost maximum by default out of the box. And we can increase that and decrease that right down to, that's the absolute lowest. So even at the absolute lowest setting there, it's still on. So there doesn't appear to be actually be an option to turn it off there. So I guess they've done the calculations that the current draw from the LEDs right at the absolute minimum is absolutely negligible. Go figure. And the other thing is I can't really see any flicker on there at all as well. I can see it certainly stepping through that brightness, but on camera, shooting this at 25 frames per second, there's no PWM flicker on that at all. So maybe they're not PWMing that, they've actually got an adjustable constant current through all those LEDs. But I really like that. That is neat. And it is so even on the display. It's absolutely incredible. I found something rather curious. Check this out. The Kindle is turned off at the moment, but I was just pointing around here and I can make this thing switch on. Watch this. Hang on, it was. There we go, look. I just switched on the Kindle. Go figure. Switch it off. There we go, it's off, and I can, maybe if I touch that part of the circuitry, which is part of the LED driver circuitry around there, it switches the Kindle on. Go figure, because there's a little 4-pin device down in there with a cap, and there's a little 0402 resistor or something like that. But yeah, look, that is just, it's all over the place when I get near that with my metallic screwdriver. Hey, look, I wasn't even near it and it switched on. There's something really weird going on there. Let me switch this. That little tack switch is hard to get. Switch it off again. No, it's not. My finger's not doing anything there. But I am able to make the damn thing switch on with my screwdriver. If I don't touch it, so I'm not imparting any 50 hertz directly onto that. Hey, there we go. I touched the LED. Bang. Straight on. Weird. Now these 4 LEDs here, they are actually mounted on this flat flex, this white flat flex cable over here. And if you look on the back here, that's where it connects to there. And you can just pop that off. You just lift it off. It's just got one of those little board-to-board interconnect connectors with the flat flex cable there, and that plugs in. And I can prove that by now switching it on, and we're getting no LEDs at all. But if we connect it, bingo, our LEDs are on. So clearly this little bit of circuitry down in here is the LED driver, probably some sort of programmable constant current driver. And there it is up close. There's a little 6-pin chip there with a cap. It looks like a diode there, and another cap, and a couple of resistors or inductors, and a big inductor there, and that's about all she wrote for that LED driver. And of course the magic with this new display here, let me switch it on, too easy, I can just touch that point down there, I love it, is the evenness of this backlight here. But it's not a backlight, it's actually a front light. It's a nano imprinted diffusion film that sits on the very top of the device here, with the capacitive touch layer underneath that, and then the e-ink display under that again, so it's actually reflecting the light downwards, so it travels out of the LEDs into the diffusion layer, spreads it all out, and then points it downwards into the screen, and then reflects back out. So it's not pointing directly into your eyes, so you don't get any fatigue from reading this thing. It's absolutely brilliant. And Amazon themselves liken it to basically a flattened out fiber optic cable, but that's a pretty crude description of it, really. There's, you know, a lot more into it than that, as far as the dispersion of the light inside and then directing it downwards. Very advanced technology. I love it. And if we try and get a close-up of it in there, you can see the layer there, and it seems to be, there's a bit of giving that, so it seems to be some sort of polycarbonate material, but it's not just, you know, a sheet of clear polycarb. It's much more advanced than that. It's nano imprinted, as they say, and that there's some magic happening in there, some black magic, and that's causing the light to very quickly, once it gets out of this LED, if we try and switch it on here, can we? Can we switch it on? I was able to switch it on before. Hang on, I'm using the wrong screwdriver. Let's see. Yeah, there we go. It's on. There we go. I got it. And it very quickly diffuses out. I mean, it goes in there, so you can see it, bright hot spot around there, but really after that, it just, you know, completely diffuses, and there's no hot spots in the display at all. Fantastic. So my hat is off to the design team at Kindle, or their subsidiary that designed this. My hat's off to them. They've done a superb job in getting this light diffusion technology working. And on this part of the board here, this looks mysteriously like a micro SD card connector footprint that's designed to poke out the side of the case, or maybe not, because it's probably not near enough to the side of the case to do that. And the footprint actually seems wrong. There's eight pins there, but it just doesn't look right. There's only 3 of them actually wired up. Let's say if this is pin 1 here, 1, 3, 4, 5, 6, and pin 6, and pin 2 there is ground. Now on a standard micro SD card, I believe pin 6 is normally ground, I believe. And up on this part of the board here, they've gone to all the trouble to route it all around like this and around there, and they've put this J1 connector there, and they haven't populated that at all. Once again, very few signals actually go into the pins of that connector. So what that one's doing, and a couple of little associated devices there, little SOT23 and other things, I have no idea. And there's just more unpopulated footprints here. There's another connector here which is going off somewhere doing something, and there's another one here. Go figure. Now unfortunately all of these metal cans here are soldered down onto the PCB, so they would be a real dog to get off. And unfortunately I do want to actually keep this Kindle and use it. So sorry folks, I'm not going to be taking those cans off to see what processor and other stuff is used under there. I'd like to, but you know, it's probably not that much different from the original Kindle, from the previous Kindle Touch. And that would likely be the Freescale IMX 508, same as what's used in the Touch. That's an ARM Cortex A8 processor with a built-in e-ink display driver, specifically designed for e-ink readers like this. And we've got a flat flex cable here, which you can just lift the lever and pop that out. It's got a driver on there. It's got a barcode on the top there, so I can't get at that chip number, but that just pops off. So we'll pop off all these, and we'll take this board off. I don't expect there to be anything on the bottom. I expect it to be a single-sided load board, but we'll take a look anyway. Let's take the rest of the screws off. Aha, the battery here has an I2C bus. There it is, SCL and SDA. So that's probably got some sort of ID chip in it, and it probably may not work without if it doesn't detect that ID's there, it may not power up. Let's try it. Alright, let's actually measure the standby current draw here with my microcurrent. I've got that on microamp range, so millivolts will equal microamps. And let's measure the standby consumption. Uh-oh folks, something's gone horribly wrong. Repair needed. Your Kindle needs repair. Please contact Kindle customer service. What? Fail. No, it's all good. There you go, it's booting up. I replaced the battery on the back, so clearly that's what must happen if you try and power this thing from a battery that doesn't have the chip on the I2C bus. So there you go. Can't just power it from any source. You would have to reverse, if you wanted to hack a bigger battery in it, you'd have to reverse engineer the I2C chip in there. So I'd love to be able to measure the LED power consumption in various modes and all that sort of stuff, but no, it's a bit too much trouble. I'd really have to hack this thing a fair bit to try and do that. But anyway, I've taken the main board out, and not much doing on the back. As I said, single-sided load that lowers their component, their manufacturing cost and their manufacturing time as well. And you can see all the isolated power planes around there for the various core voltages and there's various test points around for the bed of nails test system. Aha, and I was right about this trace here being a controlled impedance trace for the antenna. I forgot all about the Wi-Fi functionality of this. There's a reason why. It's obvious now why they've removed all the copper from the top side there, because, ta-da, on the bottom side of the board, there is your Wi-Fi antenna, and they've got a matching one on the other side there as well. And if you're curious to see underneath that rubber for the LED, ta-da, it's just holding in place a little light pipe there to get the light from the LED, which is much further back in there, through to evenly lit on the front. Standard stuff. And on the bottom of the micro USB connector there, you can see the conductive adhesive shielding braid to help with the EMI. And if you check out the bottom of the case here, you can actually, well, the underside of the front of the case anyway, you can see the metal shielding braid stuck onto there. There's the, that's might even be a magnesium plastic case on the thing, but they've added the extra shielding braid on there, which is why they've left exposed all the copper on the bottom of the board here. If you're wondering why there's copper, the exposed gold there is because it matches up. Look at that, it matches up with that. So it effectively forms an RF shielding can for all of the power planes underneath there, just like you'd see in a teardown of a spectrum analyzer, for example, like the RF section of a spectrum analyzer. So they've really, the people who've designed this really know what they're doing and really wanted to absolutely nail any EMI RF interference issues totally on the head for any country in the world, any compliance standard. They just absolutely nailed it with this thing. I mean, you can't do much better than that, especially in like $120, $150 consumer item. You know, you're kidding me. And they really want to push this board down, actually squeeze it down. That's why they've got these little metal caps to go over there like that, and the screw goes down into the threaded metal insert into the molded housing down there and pushes down the board with that metal cap. It's brilliant. So everything in here is effectively shielded inside a Faraday cage. Each separate element of the system design has got its own Faraday shielded can on there. The power planes underneath that connect them all and bind the whole system together. Sounds like the Force. They're effectively, because they're pushed down with these capped screws here, effectively forming one big Faraday cage on the bottom of the board to stop any sideways leakage from the power planes. Beautiful stuff. I bet the system designers of this thing, when they had to go for their compliance testing, they probably didn't even bother with pre-compliance testing. They just went, we're going to balls this one in. They probably did. And tiny little attention to detail stuff. They've probably decided that, look, we need a little bit of extra support on the board right down in this bottom corner. So they've got the metal threaded insert down in there with this little custom aluminium plate there to sort of hold the edge of the board down. I mean, that actually might be a kludge afterwards. They may have laid out the board and go, look, we need to support it a bit more here, but we don't want to respin the board and, probably have to get it compliance tested again or something. So maybe they did a last minute thing of just, that's it. We can change it in the housing. We'll just add a thing there, add a plate, and Bob's your uncle. So that's a little peek inside the new Kindle Paperwhite ebook reader. I really like it. There's some nice technology in there. The construction build quality is absolutely awesome. Sorry I couldn't get into those cans there. I don't want to destroy this thing, but and there's nothing under the display there. Perhaps the part number for the manufacturer of the display at best, maybe. But anyway, it's a rather interesting teardown, and the construction and system design of this thing is really first rate. They've put a lot of effort, not only into the electronics side, the RFI shielding, the construction, the design of this thing, and the beautiful new light guide diffusion technology. Absolutely fantastic. My hat's off to the design team. I really like it. So if you want to discuss this, jump on over to the EEVblog forum, and if you liked the video, please give it a big thumbs up. Catch you next time.